In this question, we'll find the general solutions of separable differential equations. Here they have asked us to solve the IVP, initial value point, explicitly if possible. So this is a differential equation. You can see y prime and the equation y given. Let me write it out over here. Y prime is equal to 3 times x plus 1 the whole square and y. You can see the function and its derivative exists in the same equation. So it's differential equation. And I've clearly mentioned these are all separable. That means you can group all the y's and x terms separately. So let me move this y to the other side. Divide both the sides by y. It will be 1 by y prime equals 3 times x plus 1 the whole square. Now for the first problem, I'll do everything in detail, but the next problems will do a little lesser steps. But if you understand the concept, that's more than enough. Then you can, skip few steps. Here, what is this y prime? Y prime means we are deriving. Now this is dy by dx because it's derivation of y with respect to x. So here I write 1 by y dy by dx. So that means this is equal to 3x plus 1 the whole square. See, all the y's are grouped and x's are grouped separately. Now what about this dx? Take it to the other side. It will be 1 by y dy. That is equal to 3 times x plus 1 the whole square dx. Now we have dy dx both the sides. We can integrate this easily. So when we integrate the left side, what happens is it will become ln y, that is equal to, here look at this, we can do u substitution because it's more than one term, but if you do u substitution, you're going to get the answer, that is 3 into x plus 1 the whole square. Because this is a constant, I can directly write that. This power increases by 1. That's plus 1 and divide by 1. And then what happens is, this is it, plus c. Don't forget the plus c. Here now 3 and 3 cancels. That's good. But what we exactly want, we don't want ln y. We need y only. So as long as y exists anywhere, that's fine. We don't need to write y is equal to entirely the thing. We have to just get y explicitly, right? Just to get y with the initial condition. So now I'll take exponent on both these sides. That is e to the power ln y. That will be equal to e to the power. This is gone. It's just x. See, this is a single term. I have to take exponent for entire thing, It'll be x plus 1 the whole power 3 plus c. Now, what happens? This cancels off and y comes down. It'll be y. Because over here, y has to be positive. That's why we write this modulus symbol. Because y cannot be negative inside this, Then the ln function would be undefined. That's the reason we put these two lines. Now here what happens? We will split this out. We know the rule. If we have EA plus B, the power, we can write this as EA multiplied by EB. Or if these two are given, see the bases are same and the exponents are there, you add them up. Now I'm going to split them up. It'll be E x plus 1 the whole power 3 multiplied by e to the power c. See, they have given us an initial value. Why they give? Now you can remove this modulus because we have exponents on both the sides. That means the answer will be positive itself. Now, because anything raised to the power, even if you take a negative number or a positive number or 0, it'll be positive answer itself. So you can ignore this modulus now. Or you can write it up to you. Now y of 0 is there. That means if y of x this is basically y of x value is 0. If you put this x 0, what is this here? It'll be 1. So I'll write it out over here. Y of 0 is equal to, here it is, e to the power, this x is 0 plus 1 the whole power 3 multiplied by, now this is multiplied by EC. Now this is just a constant. Now I won't write it as C, but I'll write it as A. It's absolutely fine because whenever you've taken the constant of integration to the power, you just write it as A. Even you can write it as C, it's fine. That is the constant we are looking for. Now substitute. We have substituted. Now substitute this value. Here we have e to the power 0 plus 1 is 1. 1 raised to power 3 is 1 raised to power 3 will be 1 itself. So it is 1 here, okay? And then, or you can just do it, e raised to power 1 to the power 3, that will be 1 raised to power 3, that is 1 itself. and then we have a. So just take a to the other side. Now when you take a to the other side, it'll be 1 divided by e, that is equal to a. So what we did over here is to find the value of this e to the power c or a, because here let's just write e to the power c, we have taken it as a, or you can write it as e to the power c, it's up to you. So the final answer would be y equals e to the power x plus 1 the whole cube multiplied by 1 by e. So that will be the final answer. So that is also included. So this entire thing, this power, is the final solution. So we have to solve it, group it out, y's together, x's separately on the other side, and then we integrate it and try to find y, and then use the initial condition and find the constant value. Here we can see the answer is, now they have written 1 by e first and then e to the power, it's absolutely fine. So that's it. And they have taken this as k. Now I have written it as a, right? Or c e to the power c, that they have taken it as k, it's absolutely fine. Anything is correct. As long as you know what that means, that's okay. And what about this one? Now I'm going to do a bit fewer steps. See, I'm going to take this to the other side directly. It'll be y power 2, but I know y prime will be dy here and dx to the other side. So here I've just skipped the first two steps. Directly take it to the other side, write dy, and here x minus 1 dx. Or you can write y prime and directly integrate both the sides. That is also fine, because you can write the formula of y prime as integration of these two. It's okay. Now when we integrate it, what happens? It'll be y power 3 by 3, that is equal to, here now it's x minus 1. So here, don't think, okay, this is power 1 and it'll be power 2. That'll be wrong. Why? Because these are two terms, you have to integrate them separately. Integration of x minus integration of 1 dx. That's how we do it. Now, if you're doing this power 2, then it's wrong. Okay, that's not the true way. You need to first do it only when there is power, then you do u substitution. Now, we're not going to do u substitution here. We are going to integrate x, that will be x power 2 by 2 minus x, because integration of 1 will be x plus c. Okay. Now I have got y, so I don't need to bother to take everything to the other side. Why? Because I can do it. You will get a different c value then, but it's just way too complicated. Why? Because you're taking it to the other side, 3. Then you're taking cube root. Rather, I'll just leave it like this because they have told explicitly. I've just done it. Explicit differentiation is done. Now what I'm going to do is put in the initial value. I know y value will be 2 when x is 0. So I'm just going to substitute 2 here. Wait a minute. Let me just change the color here to understand. This is what I'm using now. 2 to the power 3 by 3 equals 0 power 2 by 2 minus 0 plus c. So that is what I did, the substitution. Now what is the value of c? The value will be 2 power 3, that is 8 by 3, that is equal to 0 minus 0. I'm just not going to write that. 0 and 0 is equal to c. So c is 8 thirds, 8 by 3. And what we do is we substitute back in the original function. See, this was the original value, right? So we write it over here. Y cubed by 3 equals x squared by 2 minus x plus 8 by 3. That is it. That is the answer. Now you can write the extra steps if you want, because there are only 4 steps, but this is it. These are the main important steps. You can, if you have understood this, you can directly write this and you should get the full marks over here as well. That is it. And what about this one? Again, it's similar. We take y to the other side. It's going to be y into dy. That will be equal to 4x squared into dx. Now what we do is we take the integration on both the sides here. It will be y squared by 2. That is equal to 4 remains. It will be x power 3 by 3 plus c. Now I'm going to substitute this here. It will be 2 squared by 2. That is equal to 4 times 0 by 3 plus c. So what happens? 2 squared is 4. 4 by 2 is again 2 is equal to c. Now this is it. We substitute back over here. You need to write it in order. So y squared by 2 is equal to 4 times x. Sorry, it is no need of the bracket. You can just write 4x cubed by 3 plus 2. This is the final answer. Here we go. That's it. Now, again, another simple one. So we'll take y to the other side. It's going to be y into dy. That will be equal to x minus 1 into dx. Integrate on both the sides. Remember here, when you integrate it, separately you need to do it. It's not x minus 1 as a whole term. It's integration of x minus integration of 1. So here you get y power 2 by 2, that is equal to x. We have done a similar one, only the thing was it was x power 3 here, x power 2, and then it became y power, it was y power 2, it became y power 3 by 3. And this is x power 2 by 2 minus x plus c. Now I'll just substitute what is the initial condition. It's minus 2 the whole square divided by 2, that is equal to 0 squared by 2 minus 0 plus c. So the c value will be equal to, what is minus 2 squared? It's 4. 4 by 2 is 2. Answer is 2c itself. So therefore y squared by 2 is equal to x squared by 2 minus x plus 2. It's plus 2, it's not minus 2c here. Minus 2 the whole square will be positive 4, and divided by 2 is positive 2. So therefore it is 2. And here we go. What did they do over here? No, this is wrong. They have written the answer of the previous one. See here, you put minus 2 the whole square. What we have done, what is the answer? You can use your calculator. It is not 8 by 3, it is 2. You put it in the calculator, you will get 2. This is absolutely wrong. Here it should have been 2. Everything else is correct. Please note here, the solution set answer is wrong. It should be plus 2. That's how we solve it. Okay, here now we can see it's not initial values like before. See here it was y of 0. We have got y of minus 2. But that doesn't make any difference. Only the x value will be minus 2 and whatever is the y value will be 1. That's simple. You'll solve it up. Y to one side. Look here, don't take the x to the other side. It's y towards the other side. It'll be y 1 by y. Y prime is equal to 4 divided by x plus 3. This is basically dy by dx. Let me write that. Here it is dy, and over here we have dx. We need to integrate it on both the sides. Now what happens? What is the integration over here? See here, when you're integrating this, you can do u substitution, but when there's a relationship, look at the denominator. It's x plus 3, right? I'm going to use this property because it's very handy to integrate. Now, imagine it's 1 because you can take 4 outside. X plus 3. I'll write this out. 4 will be over here. Now, only I'm focusing on 1 by x plus 3. Let me write it over here. X plus 3 dx. Now, this side, it's very simple. Ln y. That's it. Now, here I'm integrating this. If the denominator, I derive this denominator. What is the derivation of the denominator? It is x plus 3 derivation, that is d by dx. That will give me 1. Why? Because derivation of x is 1 and constant is 0. Now, if the derivative is up over here in the numerator, then the rule is they are in relation. What relation they are? This function, if this is u and the below one is u prime. See here, if you have u, then u dash derivative, right? No, I've written it wrongly. U and u derivative dx, the integration for that will be ln magnitude u. So I can just write ln magnitude x plus 3 for this directly. So I'm going to write that over here, ln y, that is equal to 4 outside, and then we have ln x plus 3 plus c. This is what happens. Now I can take this 4 to the other side because the property of natural logarithm, before I remove this ln, the property says if you have a coefficient of ln, then you can take it as power. So what I will do over here is ln x plus 3 to the power 4. It will be over here to the power 4 to this x plus 3, not over here, plus c is equal to ln y. Now I'll take exponential on both the sides. What will happen if I take exponential? The ln goes, so I'll write e. Sorry, I'm not going to write e because that's just going to remove it off, right? So here it will be y. And here what happens is you will have this c, right? So here e raised to the entire thing. Please remember when we raise it up, this is a single term. Yes, ln x plus 3 the whole power 4, right? Then we have plus c. So now this will be split up. How do we split it up? If you have e to the power a, e to the power b, this will be ea plus b. So now we have ea plus b, so we split it out into e ln x plus 3 the whole power 4 multiplied with e power c, and that is y. I'm not going to write because it's exponential. The modulus is not required anymore. But see, many of these steps can be skipped. From here, you can directly jump to this step. Why? Because when I look at it, I know the denominator, the integral is ln x plus 3. That's natural logarithm. And then from here, I can directly write this. Why? Because over here, when I take exponential on both the sides, now this needs to be remembered. You have to take it to the power 4. Then write y directly. And over here, I'll remove this and write, see here, I'm going to write this x plus 3 the whole power 4. Directly from here you can, because ln goes off. But here it's plus c, so therefore it will become multiplication of e power c. If it was minus, then you should write division. But here it's always plus c, right? That's why we write that. This is it. Now it's not over. We need to put up the initial values. What is the initial value we have considered? So for y of minus 2, that will be equal to it's y of minus 2. The value of x will be minus 2 plus 1 the whole power 4 into, you can take e to the power c as a. I was doing that before, right? Because like instead of e to the power c, just take it as a, it's easier. Now what is this minus 2? It's 1 equals minus 1 to the power 4 is 1 itself times a. So what is a value? A is 1. So what happens here exactly? Here, y is equal to x plus 3 raised to the power 4 times 1. But that is it. This is the answer. That is the final answer. Now you can write modulus. Okay, they have written the modulus. You can write, because the reason for that is there is still a variable x. X can be anything, right? So please have a mod, but no, you don't need to, because this is raised to the power 4. So it doesn't matter what, it'll be a positive number. So here the domain is satisfied. No need to write that. Or if you write it, it's up to you. So here we go. That is the answer. What about this one? This is simpler. Why? Because we take it to the other side. It'll be 4y plus 1 times dy. That will be equal to 3x dx. Now here we have 4y squared by 2 plus y, that is equal to 3x squared by 2. And next what we do is basically here simplify. Y squared plus, it's 2y squared plus y is equal to 1.5 or 3 by 2 x squared. Now I'll put in the initial value. Y value will be 4. It's 2 times 4 squared plus 4 is equal to 3 by 2. I forgot to write plus c. Apologies for that. And then here x value is how much? 1. It is 1 squared plus c. So here 4 squared is 16. 16 times 2 is 32. 32 plus 4 is 36 is equal to, here what is this? It's just 1.5 plus c. So I'll take this to the other side. It's going to be 34.5 is equal to c. So that is the c value. So what you can do is you can just write it out over here in this equation. See this one, the simplified one. 2y squared plus y. See, we have all in terms of y. We have done explicit difference. Explicitly we have solved it. So that's fine. 3 by 2 x squared plus 34.5. That must be the final answer. Here we go. Now they have written 69. Let's just do this. It should be 34.5 times 2 by 2. So it'll be 35 times 2 is 70. Yeah, 69 by 2. Yes, that's correct. It's the same thing. You can just use the calculator here. If you put 34.5 directly, you'll get 69 by 2. Or if you press SD after putting this, you should get 34.5. It's the same thing. And yes, the values are correct. In this problem, we have trigonometric function. So what we do is basically same thing, integration. It's pretty simple. Let's take this to the other side. It's cosine. Okay, now don't think this is prime here. This is comma for this term. Okay, this is it. It's cosine y. So cosine y into dy is equal to 4x into dx. What is the difference here? Integration on both the sides. Integration of cosine y It is sine y is equal to 4x squared by 2 plus c. Now here sine y, let be. You can take sine to the other side. The reason I'm saying is, sine, if you have y power 2, y power 3, it's fine. But this is inside a function. So what we'll do is we'll take it to the other side. But before that, first let's find the constant of integration and then we'll do that. Okay. So here sine y is equal to 2x squared plus c. Let's find the c value. We'll substitute over here 0 and 0. So sine 0 will be equal to 2 times 0 plus c. Sine 0 is equal to c because this is also 0. So therefore we have sine y is equal to 2x squared, right? But what you can do is y will be equal to sine inverse of 2x squared. So that can be the final answer, or even this is absolutely fine. So let's look into the answer. They have written, yeah, sine inverse. Okay, now I'll tell you what is this. This is very important. What is the domain of sine inverse function? Sine inverse x is -1 to 1 because you won't have any values other than that. That's the range of this. Range of sine is the domain of sine inverse, right? So these are the values. Now here, instead of x, what do you have? You have 2x squared. So it is not x should be plus or minus 1. Now I'm just going to use equal to because I'm solving it up. It should be within that range. Now I have here 2x squared is equal to plus or minus 1. So let me take 2 to the other side. It will be x squared is equal to plus or minus 1 by 2. Let me take square root on both the sides. X is equal to, it'll be square root of 1 by 2, or it'll be plus or minus 1 divided by root 2 because square root of 1 is 1. So x has to be, see, minus 1 by root 2 will be x must be greater than that and less than positive 1 by square root 2. That's how we get the domain. See, this is the domain of the x function, sine inverse for 2x squared. Now another one, it's tan over here and it goes to the other side. So it'll be 1 by tan. So 1 by tan y will be dy will be equal to 1 by x dx. And we have pi by 2. It is similar to what we did just now. But how would you solve this up? Here, this is cotan, right? Cotangent y dy is equal to 1 by x dx. But do you have any formula for cotangent y directly? Now, if you have remembered ln sine, modulus of sine x, that's integration of cotangent is ln modulus of sine x. If it's y plus c. If you remember this, well and good. But otherwise, I'll tell you how exactly you'll get it. Cotangent is what exactly? It is cosine by sine. So cosine y by sine y. This is what I'll have to derive, isn't it? It's 1 by x dx. So what happens in the denominator? Denominator, it is sine y. Now, what is the differentiation of sine y? It is d by dx of the denominator sine y is equal to cosine y. So here when I derive this denominator, I'm getting the numerator. So the answer will be ln the modulus of whatever is in the denominator, and that is it. This will become the answer here, and this is ln x plus c. So this is how we get it. Now we have ln and ln. I'll just take exponential on both the sides. It's going to be here sine y, that is equal to x, but don't forget it will be multiplied by e to the power c. We have done this before. It will become e to the power ln x plus c, and then we can split this out, ln x multiplied by e to the power c, and this will become x modulus x. So this is how we get it. Now, since it was exponential, we'll just ignore the modulus. That's fine. And now what is it? We have the initial value conditions, right? So when y is 1, when x is 1, y is pi by 2. So sine pi by 2 will be equal to 1 times e to the power c. So what is exactly sine pi by 2? Sine pi by 2 is 1. You can check it out in the calculator. You should put in radian mode and sine pi by 2. Or if you know sine pi by 2 means 90 degree, I'm just going to write sine 90 degree. Okay, because pi by 2, pi is 180 divided by 2 is 90. It's 1. So here will be 1 equals 1 e power c. So basically it is e power c is equal to 1. Or you can write it as k or a, anything is fine. So now then we'll just substitute back in this equation. See, the sine y is equal to x into 1 is x itself, or y is equal to sine inverse of x. This is the answer. And the domain will be less than 1 and greater than minus 1. So that must be the answer. So here we go. That is at sine. Okay, they have just written sine is equal to x. That's absolutely fine. Sine y is equal to x is okay. Or you can take sine inverse on both the sides and it'll be y is equal to sine inverse x. So this is how we solve it. There are various different methods or different alterations over here, rather than these steps. You can even skip some steps. See, from here, you can directly write this and jump here as well. It's up to you. How confident you are, you can follow those steps. And that is the end of all the writing part questions. I hope you have found these videos helpful and beneficial. I wish you all the best for your exams. Please do prepare well in advance for your exams. Don't leave it at the last minute. And if you have any doubts, please try rewatching the video or ask your questions in the comments and I'll try to get back to you very soon. And thank you very much for your support for my channel. I'm really humbled by all the appreciation and thanks I receive on the channel. Thank you so much. I really, really appreciate it. If you could do me a huge favor, then please do share this channel with anyone who do not know about this and who could benefit from it. And if you can, please do hit the subscribe button and like my videos. It would mean a lot. Thank you very much and bye-bye for now.